Hey guys, Mr. Backerberg here. In this video, we're going to look at the relationships between the graph of our function f and f prime. So because the derivative at a specific point can be thought of as a slope, we can get a pretty good idea of what the graph of f prime looks like by taking a look at those slopes at different points along the graph of f. So let's say we were taking a look at a particular function and we went ahead and found the derivative or the tangent line slope at a bunch of different points along our graph. So at point A, we found the slope to be 4. At point B, we found the slope to be 1. At C, the slope is 0. At D, the slope is -1. At E, the slope is -1. And then at F, the slope is 0. We can take all of those different slopes and plot them out on its own grid, and that'll help give us a picture of f prime, or the derivative of f. So for the graph of our function, we've got the point A, but on our derivative, I'm going to call this A prime, and I'm going to come up with the point that we're going to plot out. So point A is happening at the x value of 0, so A prime is going to happen at the x value of 0, and the y value is going to be the slope that we found at that point. So we had a slope of 4, so A prime has a y value of 4. So if I plot that out on my grid here, that's the point A prime. As far as B prime, I look at point B, that's happening at the x value of 1, and the slope we found there was 1. So B prime is going to be at the point 1, 1. For point C prime, that happens at an x value of 2, and the slope we found there was 0, so that's the point 2, 0. For D prime, that's happening at the x value of 3, and the slope we found there is -1, so I'm going to plot out the point 3, -1. For point E prime, point E is happening at an x value of 5, and the slope we found there was -1, so we're going to go to 5, -1. And then lastly, we've got our f prime point. That's happening at an x value of 6, and the slope we found there was 0. So 6, 0 is that point right there. So now if we connect all of those with a nice curve, and this graph is a representation of the derivative of our function f. So even though we didn't know the actual formula for our function f, we're still able to get a visual representation of the derivative using what we know about the slope at a bunch of different points. And there's a few things that I want you to notice on this graph, particularly about the behavior of this function f compared to what we're seeing happening with those slopes, or with that derivative. So where the graph is increasing, so between this x value of 0 and this x value of 2, where the graph of f was increasing, the slopes there were all positive values. Where the graph was decreasing, the slopes for those points were negative. And then any point where the slope was 0, that's where your graph changed from increasing to decreasing, or otherwise from decreasing to increasing. So that's what happened at a slope of 0. So there's a big connection to the behavior of your function compared to the slopes at those particular points. Now in this example, we're going to do kind of the opposite. So we're going to be given a graph of the derivative of f, and we're going to use it along with some other constraints to help us draw a picture of the graph of our function f. So the first constraint that we're given is we want f of 0 to be 0. The second constraint is that we're going to have the graph of the derivative as shown below. And then our third constraint is that f is going to be continuous for all x values. So I'm going to scroll down just a little bit here. So this picture on the left-hand side is the graph of the derivative of f, and that's what we're going to use to help us sketch out the picture of our original f function along with these other two constraints. So starting with a, if we want f of 0 to be 0, that means at an x value of 0, the function value is 0. So to start, we're going to put a point at the origin. Now let's go to our derivative graph and see if we can figure out what that's telling us about the function. So if we notice on the left-hand side, we've got this chunk of the graph that is horizontal along that y value of -1. Well, using what we just talked about in the previous example, the graph of the derivative illustrates the slope of the original function. So here, where we've got our graph being constant at -1, that means that the slope of our original function f is staying constant at -1. So if I want to draw out a graph that has a slope of -1 that hits the point at the origin, then what I'm going to do is go left 1, up 1, left 1, up 1, and then left 1, up 1 again. And that's going to be a constant slope of -1. So I'm going to draw that line going out to the left. And it has that slope of -1 until we hit the x value of 1. So I'm also going to put this point down here and connect that to my line as well. Then at that x value of 1, going up to the top here, now we've got a flat horizontal line along the y value of 2. So again, thinking about this in terms of slope, this is saying that our graph of f has a constant slope of 2 starting at the x value of 1 and going out to the right. So at this point that we just put here at 1, starting there, now our function has a slope of 2. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, and we've got that line on the right-hand side of our function. So using these constraints and this picture of the derivative that we were given, we were able to come up with this graph as our function f of x. That's going to be it for this video. Thanks for watching.